Good afternoon, everybody who is already here, and welcome to this week's Q&A. As always, we'll just give everybody a few minutes to join us, and then we will get started. So hello to Peter and Dev, who are already here. Nice to see you again. Hopefully everybody is well today. And yeah, we'll just give it a few minutes and then we will get started. So as always, if you've got any questions, if you pop them in the chat now, we will work our way through them and hopefully address everything. We're going to have a quick look at script-only stacks and behaviours again. That's one of the things that was in Lonnie's stack that we looked at last week that we didn't quite get to. And then we also briefly had some questions about state management in LiveCode, so we can maybe talk about that a bit. It's not something that I know loads about, but we can certainly have a discussion about some of the options that you can use, certainly on a simple level for a fairly straightforward app, some of the different ways that you can store the state. So those are things that we have already to look at, but like I say, pop any questions in the chat and we will work our way through them. My glasses are a bit wonky there. Yep, so hi everybody who wasn't here when I said hi to begin with. We'll just give it a couple of minutes and then we'll get started. So do pop any questions into the chat. And in the meantime, I will just start screen sharing and I'll get LiveCode started up so that we are ready to start. Okay, so I've got LiveCode ready. So we'll make a start, and if anybody else joins us, and as always, just pop your questions in the chat. So Lonnie has asked, how do you set up the spinner widget while the browser is loading? So I am not 100% sure how things work in terms of layering. So the easiest thing to do is for us to make a little test stack here. And I will give that a URL with LiveCode. And actually I'll make this a bit smaller, and I'll give us a button so we can reload if we want to. And then I'll take a spinner widget, which is this one, and just drop it here. Now if you haven't used the spinner widget, it just automatically spins indefinitely, so you can show and hide it. You can set the marker count, so you can have more little, I'll make it a bit bigger so we can see it more clearly. So you can control the number of markers in the spinner, and you can just show and hide it when you want it to be sort of running or not. So let's see what actually happens here, because I had a feeling that, yeah, so what's happened is the browser widget is sitting on the top there. I'm not sure you can actually put anything over the top of the browser widget, because you can see that my browser widget, that this is actually sort of on the top. It's a higher layer in LiveCode, but as soon as you make the browser widget there, I don't think you can actually put anything over the top of it. So you can't directly use a spinner like that. If you want to do things while the browser is loading, there are some messages that you can respond to. So if we have a look in the dictionary, so down here on the left, you can go directly to libraries, widgets, anything like that. So if we scroll down to where the browser widget is and click on it, then that'll give us all the things that are associated with the browser. So for example, you get browser document load begin, browser document load complete, browser document load failed. So you can use these messages to sort of control what you are showing. So for example, if you really want a spinner, you could on browser document load begin, you could hide your browser widget while it's loading, and maybe you could put a sort of temporary image in the back, but that would allow your spinner widget or your progress bar or whatever you want to use to show. And then when browser document load complete, it might be different. There's also frame load begin and frame load complete and navigate begin and navigate complete. So it'll depend on exactly what you're doing, but you could use those to make the browser visible or invisible, and you would show the spinner while the browser is invisible. And then when you get either a complete or I guess a failed message and you want to update the screen, you can make the browser visible and hide the spinner or show a message. I think that's probably the only way to do it, because a browser widget will always sort of sit on the top of everything else, just because of how it's implemented, just how the layering works within the IDE. So yes, so Dev in the chat has just said what I was saying, but because the chat is over here, I don't see it immediately. So yeah, you could hide the browser widget while it's loading, and you can use these messages to be notified when the load begins and when the load completes. And that would let you know when to show and hide things. Okay, so another question from Lonnie. Once you've loaded and manipulated a tab delimited file in a data grid, how do you save the contents of the revised data grid back to your text file? Okay, so let's have a look at that. So I'll just do another new stack. So I have a file here that I use for data grid things. I think it's on, yeah, so I'll just use this capitals.json file, which is a list of countries and their capitals. It's quite good for just general data testing. So what we will do is, let me, if I can remember what this actually, how it's structured. Let's open it up. Oh, there we go. So yeah, it's just country and city. So what we'll do is we'll have two columns. So I'll add two columns here. The first one will be country. The second one will be okay, and I'll just write a quick button script to load that file in. So we'll name this button load. So it's not a tab separated list, which should have been easier, but this should be easy enough. So we'll put URL file. It's on the desktop. And it was called capitals. Okay. Capitals.json. And we'll put that into our JSON data. And then we will turn that into a LiveCode array. So we'll put JSON to array T JSON into T array. And then to get it into tab separated data, we'll just write a quick loop. So we will repeat for each element, T element in the array. And then we'll put T element, and then it was country and tab and then the capital. And return, and if we put that after T list, then we'll get a return and tab separated list. And then we should be able to set the PG text of group. Actually, thinking about this, I probably could have set the array directly. So let's actually have a look and see what comes out of there, because if it's a numeric array, then we can actually use it directly. City and country, so that should actually work. So I don't need to do any of this. I just convert it to an array. and then I'll set the DG data of group capitals UT array, and I will check that this is called capitals because I can't remember if I named this. I did not. Okay, so this is how we load our data in, which should work. Great. So now if we were to make changes to this, so if there was a typo, or if a country's or a capital has changed, if this is if we found an old list from the 60s and things have changed, then we can change things. So for example, maybe we want to take this out and we want to save that out. So all we need to do is we do the inverse of loading in. So I'll just make a copy of this, but I'll change our save code. And I'm just going to turn up my text size because I haven't done that. So here what we did was we loaded in from file, and then we set up the array and we displayed that in the data grid. So instead, what the first thing we need to do is we need to put the DG data of group capitals into a variable. Then instead of converting from a JSON to array, we take our array and we turn it into JSON. So in that case, we use array to JSON, and we pass T array, and we will put that into another variable. And then instead of loading in from a URL, we'll write out to a URL. So instead of put URL, we set URL file, and then we'll call this capitals 2 so we can see the difference, to tjson. Oh, sorry. Let's put tjson into TRA. So property, we use set for properties, and we've put into variables and we've put into arrays. So to load, we get the data from the file, we turn it into an array, we set the array data. To save it, we get the array data, we turn that into JSON, and we write it out to file. So now, if we save, we should get a file called capitals2. Let's open this up. And we should see what we changed, which was Brussels. So I didn't do pretty print, so I'll actually amend this so that it's a little bit easier for us to see. So in our array to JSON, if we set the sort of the pretty formatting, I can't remember what the name of the parameter is, but you can check it in the dictionary. We save again. Now let's open this up, and it'll be laid out. It's just a lot more, it's a lot easier to look at. So now we should be able to find Belgium. Here it is. And you can see that that city used to have the brackets after it. We've taken those out and we've written it out to file. Now I've used the array here, so the DG data. You could use the DG text similarly. The difference is that when you're loading, you read it in from the URL and then you set the data. And when you're saving, you get the data out of the data grid and then you write it out to file. And then Peter's asked about saving to a CSV file instead of JSON. So that's actually a little simpler. So if we wanted to do a different type of saving, so we'll call this one save to. And if we wanted to create a CSV file here, instead of using the DG data, I'll use the DG text, which will give me tab separated data from the data grid. So it will effectively give me this, exactly what's here, tab separated. If we want to turn our tab separated data into comma separated data, what we can do is we can use the replace command. So we can say replace tab with comma in tdata. Now we'll need to be careful with that because there may be some commas in some of these names here. I don't know if there are any. It would seem strange if there were, but there might be a comma in there somewhere, in which case you'd have to be careful with your CSV data. You could leave it as tab tab separated data if you were concerned about that. But to create CSV data, we replace tab with comma, and then we just put that data into URL file, special folder path. We'll call this capitals 3, and then it'll be .csv. And so if we try that now, that's our save to, which creates capitals 3. And this should be, so you can see it recognizes that it is CSV data because it asked if I wanted to open that in different, there are some different options there. So I'll just open it in the Numbers app because that's the default for a CSV. That's a spreadsheet effectively. Let's see, it might take a second to open up. There we go. There is our CSV data. Because we've opened it in Numbers, it looks like a spreadsheet. But if I open it in the text editor, just don't want to save that. If we open it in a text editor, so let's just open it in text edit, you'll see that it is comma separated data there. So with your data from the data grid, you can sort of massage it into whatever form you want. If you want to use the array data to get there, or the DG text, which just gives you this, then whichever one works better for you, then you could iterate over the array and build exactly what you wanted to write out, or you could take that tab separated data that is already in the data grid and just replace tab with comma, and then you just write out to file colon, just so that LiveCode knows that it's writing to a local file, and then just the full path to the file you want to write to. Now here we're writing to file because this has just been text data. If you are working with images or anything else, then you would, in the case of images, we'd write out to bin file, which is a binary file. But here we're working with just text data, so we can just use file there. And so that is how you would write out to a CSV. It's really nice and easy to work with either CSV or JSON data and data grids, because you can just display array data, or you can display CSV or tab separated values directly just straight into your data grids, as long as you've got it set up correctly. So that's a nice way of reading and writing out your data. Okay, so I don't think we've got any other questions here at the moment, so we'll just have a look at some of the things that we didn't quite get to last week. So one of the things that Lonnie included in his stack was he was using some behaviors, and so I thought we would have another look at behaviors. I'm not going to use Lonnie's stack, I'm going to use a little example. But one thing that I wanted to tell you guys about, if you didn't already know about it, is our sample stacks button here, which I think is also called LiveCode Share and is available on a website. Now this is where our user stacks, our users have uploaded stacks, example stacks, projects that they've worked on. So it's a nice way of being able to share your stacks, libraries, anything you've done that you want to show people. Now, you can't download all the stacks and things, so it's not for anything sort of commercial. It's not a commercial thing. It's just a way to share stacks. So these are ones that members of our community have written in the past and shared for everybody's use. And there are 495 stacks on here. So Lonnie, I don't know if you might want to think about this as a way of sharing your stack and make it nice and accessible to other people. You could just put it up here and people could download it directly. So this is our LiveCode Share portal. Like I say, it's not commercial. So if there are things like widgets that people have written and they want to sell, then they wouldn't be in here, because this is all just open. You just download the stack and it's all there. So it's really just a way of people sharing what they've done in case it's useful for people in the future. So what I thought we would look at for our behaviors and also script-only stacks example is, years ago, I wrote a little stack for our newsletter for Halloween, and it's a hangman game. So in it, it was written before we had behaviors and script-only stacks, so it doesn't make use of them, but actually it's a nice example of if those had existed when I wrote it, I would have used them. So we're going to turn it into an example that uses script-only stacks and behaviors. So here is my little hangman stack, which is actually available on the sample stacks. That's actually where I got it from. It's probably lurking in my backup drive somewhere, but it was easier just to actually go there and download it. And it's just quite a simple game where you have, so this is a book. So we guess what the book is by clicking on the letters. If anybody's got any ideas, you can put them in the chat. Oh, so that's probably on. No, in. Something in Love. Guessing that's Girls in Love. That's not a book I've actually ever heard of, but there we go. And I got these, I think there's books and films and songs, and they're just the top 100 sort of voted for books, songs, and books, songs, and films. So yeah, it's quite a nice little simple stack, but you'll see, for example, all these letter buttons, these do the same thing. So these would be a prime candidate for having a behavior. So the way it works at the moment is it actually uses a group. So we don't actually have code associated with every single button, but it is associated with the group that they are all in. So on mouse up, we call check letter, which checks it against the answer that we're looking for, the short name of the target, and then we set the disabled of the target to true. Now these buttons, I'm just going to show you how they work because it's quite a neat little trick. So these have an icon. So all the icons in here were created by our graphic designer at the time. So there's an icon for A, which is just the normal one. Then there's a highlight icon, which if you can see is a little bit darker in the corners, it's kind of shaded in. And then there's a disabled icon with a score through it and a hover icon, which is red. And just by setting these different icons on the buttons, then it behaves. When you hover it, it changes. When you press it, it changes again. And when you select it, it then turns to disabled. So you can handle all that just in properties without having to write any code. So that's quite a neat little, it's quite a nice little trick to provide that sort of that feedback to the user of what state the button is in, if it's hovered, if it's pressed, if it's been disabled, etc. And if you're doing that, then you actually need to import all the images onto your stack so that these then have an icon. So you can see that's the normal A, and it's 6001. That's the hover A, 6027. And if we go back and look here, you can see there's the normal one, 601, the hover, 6027, and similarly for the highlight and the disabled. Okay, but getting back to what I was talking about. So currently this is handled in a group, which is, it is quite a nice way of doing it. You still don't have to write code for all the 26 letters, but I would have used a behavior for this if this had existed. So let's make it into a behavior. So the two ways that you can have a behavior is the behavior can be stored in a button script on the stack, or it can be stored as a separate script-only stack. So for the buttons here, for our letter buttons, I'm going to use a button on the stack. And we will give this name, we'll call this letter behavior. We want it to do pretty much the same thing that the group does, but instead of check letter the short name of the target, we'll check letter the short name of me and set the disabled of me to true. And you always need to remember to use me in behaviors so that, because the behavior can be assigned to multiple controls, me will always resolve to the control that was pressed or typed in or actually received the message. So we always want to use me. And what I can do is I can remove the group script because we don't need that anymore. And then what we need to do is we need to set the behavior on each of those buttons. Now you can do this in the property inspector by clicking on the target, select the behavior, see how it gives you the options. It can either be a button or a stack. Those are the two options. We want it to be a button. There's a lot of buttons on here, but it's the oldest one, so it's down at the bottom of the list. Button letter behavior. Now, doing that 26 times, that's a bit of a pain. So instead, what we'll do is we'll just write a quick little script to do it. And we'll use the multi-line pane of the message box, which allows us to write multi-line scripts. It's already in here because I was testing it earlier. So we repeat with t_button equals 1 to the number of buttons in group alphabet, which is our group. So that'll be 1 to 26. And then we just set the behavior of button 1 of group alphabet to the long ID of button letter behavior, which is this one. And then it does that for button 2, button 3, button 4, all the way up to button 26. Just run that. Now, if I pick any of these buttons to have a look at, all their behaviors should be set. And if we now try and guess our book this time, you'll see that those are still behaving as they should. So there we go. That's our letter behavior. And you'll see that's up there because of the layering. So that's sitting there. So actually, we probably just want to make that invisible. We don't need to be able to see it. But our buttons now work. And we've only written that little bit of script. And we've used a behavior to do that. So that's the first way to do a behavior, is to create a button script and then assign the behavior of the controls to that script. And if we have a look at our project browser, there's our Hangman stack. Run the game card. There's our alphabet group with all our 26 buttons in it. And you can see that they all have no script of their own, but they do have a behavior script. And from any of these, we can open it up. So that's the first way to do a behavior script. Next, we'll look at script-only stacks. And what we'll do is if we have a look here, you'll see that this card actually has quite a lot of code in it. So we're going to turn this into a script-only stack instead. And I think we talked about this before, but one of the reasons for doing this is to make using version control systems, whether that's Git or anything else, a bit easier, because this is actually now going to be just a text file. And that's much easier for these systems to deal with in a way, because you can see all the differences in them. They can be compared easily, much easier than with an actual binary stack. So if you're working on your own, it's not such a big deal. But if you're working with a team, even if there's just 2 of you, that can be really helpful. It also helps you split out your project into multiple files if all your scripts are files, and then you've just got your UI as a stack if anything goes wrong. So if you change one of your scripts and your project stops working, if you've just got one big binary file, it can be quite hard to know exactly what it was, but you can look at your individual files, you can see which ones have been changed. The chances are that if it's one you changed today that made it stop working, you know where it is. Also, if your stack becomes corrupt or anything, then that could be your whole file, or it could just be one file. So they're a nice tool. We use them a lot. All of the LiveCode IDE itself is written with script-only stacks. I can show you that in the project browser, actually. I'll do that after, though. Okay, so here is our card script. We're going to turn this into a script-only stack. So the first thing to do is to create a new script-only stack. We go to File, New Stack. We want it to be a script-only stack. And we need to give it a name here. So we will call this, so it's the card named game. So we'll call this game behavior. And so this has now created us a stack game card behavior. We're just going to copy all the code into here, just using copy and paste, and then we will delete it from here. And let's apply both of these. And now we need to save our script-only stack, just using save. And I'm going to put it into my Hangman folder. And now I'll show you what happens with behaviors on cards. So if we go to the card inspector, go to this pane, again, choose the behavior. We can select the behavior. This time it's the stack and it's our game card behavior. And so now our stack should work just like nothing has changed. It didn't work. So why didn't that work? Oh, is our behavior set? Ah, it didn't set the behavior, that's why. So we'll set that again. It didn't seem to save it. So select the behavior, choose the stack game card behavior. It's definitely there now. Yeah, so now we can see there's our behavior. It should now work. So again, we've got a book. Choose some of these. My random guessing is not going very well. Choose a new one. So we can see that our card is still behaving like it was before, as if nothing had changed. Now, if we save this, we'll quit and then we will reopen it. I don't need to save these. So in my Hangman folder, I'm just going to reopen my stack and we'll see if everything's working. And if we go to the project browser, we will see that we have a red icon here. And that's because the behavior is still set, but it can't be resolved. So you can see if you hover over it, it says missing stack game card behavior. And that's because the stack, our script-only stack, is not open in memory, so it can't be assigned. So what we need to do is we will open our stack script and we'll add a pre-open stack handler. And in here, we're just going to open that stack so the behavior is assigned. So we set the behavior of card game to stack. And then because it's a script only stack and it's actually a separate file, we're going to give the file name of this stack here. So it'll be in the special folder path resources, which is the same folder that the app is actually running in. And this will work if you were to deploy this either to desktop or to a mobile app. What you need to do is you need to remember to include all your script-only stacks because they are actually separate files. So you need to include them in the same way that you would include images or sound files or anything else need to be included with your stack. And then it was called game card behavior. And it's .LiveCode script. Okay, so now when the stack is opened, that behavior will be assigned to this stack, which we refer to by its full path. So if I just call pre-open stack from the message box, I've made a mistake there. So the behavior of card game to the long ID of stack. I think that's what I missed. So there, now there's no error. You can see that our game behavior has gone blue, so it's resolved. We can find it. I can click on it. It opens up. All the code is in there. And this should work. So there is our card behavior all working. And like I say, if you were to build this into a standalone application, you would just need to remember to include your script-only stack in here because it is actually a separate file. And then it'll work. And if we open this up, we can open this up in a text editor. So I want to choose a text editor rather than a LiveCode. I mean, you can open it in LiveCode, it'll open up in the script editor, but just want to show that it does open up in For example, this is Sublime Text. This is the text editor that we mostly use for working with script-only stacks because there's a LiveCode formatter available for it. So you can see that the text is all colorized and highlighted like it would be if you were actually working in the script editor, and that just makes it much easier to work with. But you can see now that this is just text. We can make changes in here in our text editor, save them, and it's as if we'd made the changes in LiveCode. So that is the second way that you can use a behavior. So the two options are, a button on the stack or a separate script-only stack. Now, the other thing you could do is, if you wanted to, is you could have your script-only stack as a substack of your main stack, and then it's still sort of, in that case, it's still all in one file. So it's separated out partially, but it's still part of the main binary stack. So you could have your game card behavior as a substack of your main stack, but then it's still just one file. So I wouldn't do that very often because the point is to sort of be able to separate it out. So yeah, so with script-only stacks, that's mostly to take advantage of it being stored in a separate file, and you can use the software and the features of sort of version management software with using a button as a behavior. That's more to take advantage of using behavior so that you don't have to repeat code, that you can just make changes in one place. You can have reusable code for things that are used in multiple places. So those are the two main uses of behaviors and how you would use them in your app. Okay, so Lonnie has now said that his stack should be available on the sample stacks, and he's got some other stacks as well there as well. So that's great. I'm really glad to see that you guys are managing to use some of this stuff. And like always, I will put all this in the slides for you to be able to look at afterwards. Okay, so that was our hangman game, sort of behaviorized, as it were. Now, the other thing that came up last week that we didn't get to was sort of talking about state management in LiveCode. And again, like I say, that's not something that I'm super familiar with, but we can certainly have a look at some of the ways that you could, some of the options for how you might want to manage it. I did have a bit of a look around at what's available, and I asked the dev team as well if they have any ideas. And unfortunately, we don't have any state management libraries or anything provided or already implemented that people can make use of. But I think, just as a very sort of basic example, this should be kind of useful. So a lot of the state management of LiveCode is actually the sort of the properties on your objects and things. So you can change the properties and the appearance and the state of things will change. It'll depend, things are disabled or enabled, showing different things. So a lot of the state is actually sort of managed within the controls themselves. Now, of course, once you have built a standalone, then any changes that you make while you're using it, those won't persist. So for example, here, if I highlight that, if this isn't a standalone, if I highlight one of these, I reopen it, it's not going to be highlighted anymore because it will revert to the sort of the state it was in when it was saved. But what you can do is you can use the state of the control to save itself. So for example, this is a little shopping list. Now, our item list field, at the moment you can only select one item at a time, but we can change the properties so that we can have non-contiguous multi-line highlights, which means that we can select, using our control keys, we can select multiple items here. So effectively, the state of the shopping list is actually stored in the properties of this list. Now, of course, the problem is that that's not saved, so we need to save it. So the first way that you can do it is you can just get the current properties of your control, and you can save that out to a file, and then you can load that back in. So if we select some items here, So let's do it in the card script, so just to make it sort of automatic. What I'll do is I'll add a close card handler. So when the card is closed, we want to save the selected items. And then when the card is opened, we want to load them. So on close card, we would save them. On pre-open card, we would load saved items. And the easiest way to do this is to get the highlighted lines of the field. So in the message box, if I put the highlighted lines of field, I think it's called item list. So it's lines 4, 8, 22, and 23. So the easiest thing to do is just to save those. So kind of like we did with the example with the capitals and the data grid earlier, what we'll do is we'll put the highlighted lines of field item list, and we'll save it out to a file. And again, it's going to be a URL. It's just going to be a file. It's just going to be a text file. And again, we'll use special folder path resources, and then we'll give it a file name. So it's URL file, it's special folder path resources. And we'll just call it items.txt. So when I close, the close card message will be sent when I go to a different card. So I'm just going to use this My List button to go to a different card, and then we'll have a look on the desktop, and we should have a file, item.txt. Let's open that up and see what's in it. There's our list of items. Now when we go back, this has been reset. So on pre-open card, again, similar to what we did before, but we want to set highlighted items of field list. Instead of putting, we will set the highlighted lines of field item list to whatever is in our URL. So we've saved them. Now we want to set them to whatever is in that file. So if I just call pre-open card from here, and those get highlighted. So on close card, we can save the highlighted lines. On open card, we can load those back in. Now here, I just directly put it into a file. And that's fine because this is a really small example. You might want to be careful of things like that, because if you have a larger app and you are writing out to file to save your state all the time, that could be quite intensive. It could end up being an intensive amount of work. So you might not want to do that all the time. So in that case, what you could do is you could store the state within the stack itself, so that when you're moving between cards, you still have access to the previous state, and then you can just write the whole state out to file, perhaps when you actually close the stack. So rather than rewriting it out to file every time you move cards, you would just store it on the stack. So in that case, what we could do is on close card, we would call a command, save items, and then we would perhaps pass the highlighted lines of field item list with it. Save items. I'll delete that. And then on close card, we would just load items. Or perhaps actually what we would do is we would save the items out. We would get here. So here we would put saved items. This will be a function into t items. And then we would set the highlighted lines field item list to whatever is returned from t items. And then what we can do is we can actually save this perhaps on the stack itself. And that's because we might want to be able to access the same data, but from a different card. So for example, here we've got things selected. We might want to go to My List, which would just have these items in it. So we want that to be accessible from the My List card and from the All Items card. So we'll save it to the stack. So I will open up the stack script. And what we need to do is we need to implement our command save items. So this is a command. And our parameter will just be p item list. And then our function was saved items. This is a function. And one way we can do it is we can use a script local variable, which we've discussed. So this could be our s item list. So this is stored in a script local variable on the stack. So both of these, this command and this function, we'll be able to access it. And we would just put p item list into s item list. And because it's a script local, that will be saved, or it'll be accessible. And here we will just return s item list. If we come back here, let's do asparagus, apples, and avocados, all the A's. If we go to a different card and come back, then those are loaded, and we haven't done any writing out to file at that point. So we don't actually have this file anymore, but let's do zucchini this time and come back, and it's still highlighted because this is persistent, because this is on the stack script. So even though we're switching cards, this value won't change, won't be reset until we reopen the stack. And if we want this to be persistent, what we would do is we would, on close stack, we would do what we did before. We would put s item list into the file, into URL file, special folder path, resources. We'd write that out to file, and then when the stack is opened, so in this case we would do it on pre-open stack, we would put what's in that URL into our local variable, so into s item list. So that will update that script local variable with whatever was in there before. I need an ampersand there, and I copied it, so I will leave it there as well. And now we'll actually only write out to file or read in from file when the stack, the whole stack, so the whole app, is opened or closed. So that will reduce the number of times that you're actually writing out to file. So we'll be keeping it up to date here when we're changing card, when we're closing card or opening card, but we won't be writing it out every time. So this won't actually be written out until we actually close the stack. And then you can see it has been created there, and we should just be able to reopen it from here, and it's read in again. So we're reducing the number of times that we have to write out. And then equally, the other way that you could do this, so this, if we did this for everything that we needed to store, we could end up with an awful lot of script local variables. So this is another place where we could use custom properties instead. So instead of putting this into a custom property, we could, instead of putting this into a script local variable, we could use a custom property. So in that case, we would set the C item list of this stack to S item list. We don't need our script local variable there. And then in this case, we would return the C item list of this stack. And the same here, we would put the C item list of this stack into URL, and we would set the item list of this stack to whatever's in that URL, and then we don't need into S item list on the end. So by doing that, we can just have a list of custom properties. So if we have a look at the stack inspector, we would be able to see our custom properties here. So actually, if I choose some things on here, you can see, so that should be P item list there. Let's go back and do that again. So there, our C item list is now a list. And when we go back, it's been set again. Again, we haven't written out anything to file, but instead of using a script local, we're actually using a custom property, and that can then be accessed anywhere because it's a custom property of the stack. And if you wanted to, in that case, instead of in your closed stack and pre-open stack having to go through every single custom property individually, you could just write all the custom properties out from there. So you can get the custom properties, you can write a repeat loop to do it. Or alternatively, what you could do is you could create a custom property set. So we could call this C state. This is effectively like an array here. So our C, what did I call it? C item list could be a custom property of the C state custom property set. So if we put some numbers in there, and I'm just going to delete our C item list here just so that we can see what is happening. So now what we've done is we've created a custom property set. So you can have as many custom property sets as you want. Anything that you create that's just a custom property will just go into the general set, but you can have custom property sets. So those are effectively, they're like an array with all the elements being the custom properties, but you can group them together. So in this case, instead of just setting the C item list of this stack to P item list, we set the custom property stack, set the custom property set. So we set the custom property of this stack to, it was C state, I called it. And then we'd set the C item list of the stack to P item list. Now, I'm now doubting myself. Am I doing this right? Let's look up custom property sets. So this is going to give me an example of how to use it. Yeah, so this is what we want to do. So I'll just copy that. So I don't need to do this. We'll set the custom properties C state of this stack to, and then what I will, so first things, because this is going to be an array, let's do this first. So we'll put the C item list of this stack into T array item list. And then we'll set the custom properties C state of this stack to our array of properties. Now let's check that this works as expected, because I'm not convinced that I have got that right. So let's go to my list, open up the stack inspector, go to the custom properties, choose the state, item list is empty. So I didn't get that quite right. Maybe that needs to be like that. still not quite right. This might be something I need to follow up in the... that's why, because I'm not putting anything into item list. So, because that should be p item list, of course. Okay, so that's our parameter. We put the p item list, which is passed in here. So actually, let's just put p item list into t-array item list, and then we set the custom property C state of this stack to t-array. So hopefully that should now be as expected. Stack inspector, custom properties. There's my state, and the item list is now 5, which is as expected. And then because we have put everything into a custom property set, which is effectively an array, when we close the stack, what I can do is I can put the custom properties C state of this stack into an array. That's now an array. And then what I can do is I can put array to JSON, array into our URL, but let's call this props.txt. Save that. And now what I need to do is I need to close the stack. We should now have a props file. And it has our item list in there. And the nice thing about doing it this way is because we're putting it into a custom property set, then that's all that our close stack has to do, because it just gets the whole set of custom properties and write them out to file. And obviously we would also update pre-open stack to read in and convert it to an array, and then set the custom properties C state to the array. And so the close stack and the pre-open stack are nice and simple because you're just writing out the whole array of custom properties and reading in the whole array of custom properties. And then you just have your commands and functions for actually handling the individual properties. So those are some ways that you can sort of work with a bit of state management in LiveCode. You can do the simple stuff. You can just write straight out to a file. You can use custom properties and you can write those out to individual files. Or you can create a custom property set, and within that set you have all your individual properties for storing the state, and then you can just write that whole set of properties out and read them back in. And it'll depend on how complicated your app is, which method you choose, because you don't want to do something super complicated if you're only going to be storing 4 or 5 different properties. But if you are at some point going to be storing 500, then maybe you do want to use a custom property set. And that's another place where you can do things like you can use the get and set prop handlers, which we've discussed before. So when you're setting a custom property, as well as just using that custom property to store a bit of data, you can give it a get prop and a set prop, and you can actually do things when the property is set. So if you change somebody's role, so if you set the C role of the stack to user or admin or whatever it might be, then actually when you change that role, when you change that property, you might want to be able to show different items, you might want to disable things, you might want to enable things. So when that property is set, you can add a set prop handler, and in there you can do all the things that your app needs to do when that property, when that state changes. And so a combination of the custom properties, the get prop, the set prop, and always having to remember to write out and read in from file, because those properties will not be persistent between uses. That should give you a way to manage some level of state within LiveCode. I'm guessing that at some point we will provide some kind of state management library. Maybe somebody's working on one already. That will mean that that you guys don't need to keep reinventing the wheel, as it were, but we don't have that at the moment. Okay, so hopefully that was somewhat helpful. As always, I will put everything into the slides that we send out, and hopefully that has been a useful session for everybody. So thank you again for coming along and for your questions. hopefully that's useful. And as always, we'll be sending out the slides along with the link to the video when it is available. So thank you, everybody, and have a lovely evening. Thanks, Peter. Thanks, Gabby. Thanks, Lonnie. As always, like I say, if you've got any sort of larger questions, you can always send them to support@LiveCode in advance. I can take a look at them before we get to the session. So if you do have anything, then you can always send them in, and otherwise I will see you all this time next week. So have a lovely evening and a lovely weekend, everybody. Thanks again.